I welcome you to this wonderful tutorial class going on, and we are here. We are going to be discussing on indices. So first and foremost, indices is the plural form of index. So that means if you are having index here, we are going to be having power 2. Why? Because index is the same thing as saying power. So it's the same thing as saying exponent too. Exponent. So firstly, if you are having something of this nature, which is 2 raised to power 3, that means this is trying to tell us that this power will is telling us how many times we have to multiply this 2 to give it a product. So if it's like that, 3 is what you are having as the power, 2 here is what you are having as the base. So that means 2 is going to be multiplied in 3 places. Why is it going to multiply in 3 places? It's because it's 3 that is telling us how many times, which is the power, is telling us how many times we are going to multiply. We are going to multiply. For example, if you are taking 3 raised to power 2 as an example too, we are going to be having 3 times 3 in 2 places. Why? Because this 2 here is telling us how many times we have to multiply this 3 to give it a product. And that's why we are having this as 3 multiplied by 3. So definitely, before we go into some series of solving questions, what you are going to do first is that by taking the rules of indices, and if you are taking the rules of indices, we are going to have some laws, abide by it. And don't forget to like the video and to share the video and to subscribe, most importantly. So thank you for that. Now in this process, if you are dealing with this process, let's talk about the rules of indices. Firstly, the rules of indices. And talking about the rules of indices, we are going to be talking about the multiplication law. And if you are talking about the multiplication law, it's going to be a raised to power m times a raised to power n. So in this process, this a raised to power m, like I have said, a refers to the base, m refers to the power. A refers to the base here and n refers to the power. So this a, you are having it here and you are having it here. That means they are the same thing. Just pick one out of this a here, which is equals to a. Then raised to power m. This multiplication here will change to addition, which is plus n. So e.g. example, let's talk about a raised to power 3 times a raised to power 6. By following the number one law, as in the first law, is going to be a is common here, just bring out a, then raised to power 3, then this times we change to addition, that is plus 6, which is equals to a raised to power 9. So that is that for that. So the second law, which is talking about the division law, that is a raised to power m divided by a raised to power n, is equals to, we can easily write it in the form of a raised to power m divided by a raised to power n. So in this process, a and a is common here. So just what you have done here is going to we are going to apply here. So which is equals to, pick one out of this a, raised to power m. Division will change to subtraction, that is minus n. So e.g. if you are having a raised to power 6 divided by a raised to power 3, is going to be a raised to power 6 over a raised to power 3, which is equals to a raised to power 6 minus 3. Why is it minus 3? Is because division will change to subtraction. Now it's going to give us a raised to power 3. Now in the second process, let's talk about the third law. Let's talk about the third law. And if you are talking about the third law, I'm going to have it to be a raised to power m raised to power n. This is what we call the product law. And to solve the product law is very simple. This bracket simply means multiplication. And if you are dealing with multiplication, we all know that multiplication is what you call times. Yes. So that means we are going to add this to be a raised to power m. This bracket here will change to times n. So if you are multiplying these two together, you are going to add this to be a raised to power m n. So that is the third law. The fourth law is a raised to power zero. That is what we call a zero law. So that means anywhere we have anything raised to power zero, we all know is what is one. So in this process, if you are talking about taking example, we are going to have it to be a raised to power 3 minus 3. This is the same thing as saying this. Why? Because 3 minus 3 will give us what is 0. And if you are having this, you automatically give us what? Give us 1. So if you are having a raised to power 3 over 3, a raised to power 3, sorry, if you are having this 2 here, it's also the same thing as saying this one, which is a raised to power 0 is equals to 1. Why? Because pick one out of this a, or let's do the a times a times a. How many times are you having a here, which is 3 times? That's why you have it as this, over a times a times a. So it's now going to be a cancel a cancel a cancel a. That is equals to 1. So it's the same thing. Let's look at the fifth law, which is the negative law. And if you are having the negative law, you are going to have it to be in the form of this, a raised to power minus n. And if you are having a raised to power minus n, minus in this process, which is negative law, we'll be talking about that anywhere we see minus is going to talk about 1 over a raised to power n. Why is it like this? It's because this minus will change to 1 over the positive of what you are having here. And if we remove this minus away, what are you going to have left is what you are having here, which is a raised to power n. So e.g., if you are having 5 raised to power minus 2, for example, is equals to this minus here will change to 1 over the positive of this. And how can we get the positive of this? Is that by removing this minus, it's going to give us 5 raised to power 2. So which is equals to 1 over 5 square will give us 25. So that is that for that. So let's discuss about the sixth law. The sixth law is what we call the fractional law. And how can we get the fractional law is by using this method. A raised to power 1 over n. Can also say is we are having it to be n roots a, n root a, then raised to power 1. This process now will actually lead us to some questions, to solve some questions easily. So if you are following these laws, you are going to solve some questions easily. Now a raised to power 1 over n lead us to n root a, then in bracket raised to power 1. So e.g., if you are having 3 raised to power 1 over 2, for example, sorry, this is 9 raised to power 1 over 2. Now this 9 raised to power 1 over 2, we are going to add this to be square root. Now these two are turned to square root, and if we are dealing with square root, you don't have to put square root here for you to talk about square root, because this sign or this symbol has indicated that we are looking at square root. So if it's cube root that is here, that's when you are going to put 3 here. So to differentiate for if it's square root or cube root. Now this is now going to be square root of 9 raised to power 1 by following this law. So which is equal to square root of 9 will give us 3, then raised to power 1. And 3 raised to power 1 will give us 3. So that is that for that. So the seventh law is that, just to recall, if you are having a raised to power m is equals to a raised to power n. Don't forget that if the base are the same, we are going to equate the powers. If the base are the same, equate the powers. That means if the base are the same, cancel, we are going to equate the power. What I mean by equate is that m will be equals to n. And let's do it in the other way round. If you are having a raised to power m is equals to b raised to power m. Now in this process, the powers, which is the index or exponent, is the same. So we are going to equate the what? The base. So it's not going to be a is equals to b. So now let's solve one question before we proceed. Let's solve question before we call it a day. Let's solve one question before we call it a day. And if you are to solve one question, you are going to have it to be in the form of this. So which is simplify 3 raised to power n minus 1 times 27 raised to power n plus 1 over 81 raised to power n. Now in this process, first and foremost is that we are going to take the index of this. Take the index of these two. So let's solve. Solution. So which is 3 raised to power n minus 1 times 27 raised to power n plus 1 over 81 raised to power n is now going to give us 3 raised to power n minus 1 times, take the index of 27, 3 raised to power 3 in bracket n plus 1 over, take the index of 81 to be 3 raised to power 4 times n. So now in this process, we are going to have it to be 3 raised to power n minus 1 times 3 raised to power, open the bracket. What I mean by open the bracket is that let's solve the bracket first. 3 times n, like I've said, bracket simply means multiplication. 3 times n will give us 3n plus 3 times 1 will give us 3 over 3 raised to power 4n. Why is it 4n? 4 times n will give us 4n. So now in this process, by applying the first law of indices that we just did now, so which is pick one out of these 3 raised to power n minus 1, this multiplication will change to addition, plus 3n plus 3 over 3 raised to power 4n. And I'm going to have it to be 3 raised to power n minus, let's collect the like terms of these ones first. That means n and n will come together, plus 3n minus 1 plus 3 over 3 raised to power 4n. So we are going to have this to be 3 raised to power 4n minus 1 plus 3 will give us plus 2. Then over 3 raised to power 4n. Now in this process, we are going to be having equals to 3 by following the second law of indices. 4n plus 2, then division will change to subtraction. That is minus 4n. So we are going to have it to be 4n minus 4n, correct like terms, plus 2. So which is what you are having as this. 3 raised to power 4n minus 4n is 0. So we are left with plus 2 here. That means it's going to be 2. And 3 raised to power 2 will give us 9. Thank you for watching. And don't forget to like, to share, and to comment. And don't forget to ask questions or drop whatever question you need to be and that it need to be done. So we can just work together in this. And I hope we eventually gain one or two, or we have gained one or two here in the tutorial class. Thank you.